Today, I'm going to show you how to make this aimbot. I'm going to show you how to make it for Assault Cube, but you can take this code and reverse engineer knowledge you learned in this video to hack any game you want. This video is meant for someone brand new to coding and writing video game cheats. I will attempt to make this the most detailed aimbot tutorial on the internet. You should be an aimbot pro after watching this video. The first thing you want to do is you want to launch Cheat Engine. And we are going to search for the game mode. This is going to help us tell whether the enemies are allies or teammates. Attach it to Cheat Engine. Then you want to search for, first thing you want to do is you want to go Settings, Hotkeys, and you want to set a hotkey for change value, unchanged value. I have mine set to number pad 1 for change value and 0 for unchanged value. So you want to do your first initial scan, set to unknown initial, first scan, and then you want to change the game mode. And press 1 for change value. Then move around the game, unchanged value, move around a little bit, unchanged value, unchanged value, unchanged value. Then you want to switch to a different map. Change value, unchanged value, unchanged value. Move around a little bit, unchanged value, unchanged, unchanged, and swap map. Well, I died. Press unchanged also. Then, not swap map, swap game mode. Change value, move around, unchanged value, unchanged value. And we're going to look what we've found so far. It's going to be a green value, a static value. And it's definitely not going to be a big number. It's not going to be over 100. Because it's going to be a few values. Like how many different game modes we have? We don't have that many. So we're going to search between a value between 1 and 100. So value 1, 100, just to thin it out. Next scan, next scan, next scan. So we got these. So then we're going to go to a different mode. Change value, unchanged value, unchanged. Move around a little bit. So it should be one of these values. Let's keep trying to narrow it down. Deathmatch. What mode are we in? Team deathmatch. Change value, unchanged, unchanged. So it's going to be one of these values. So what you can do is you can change this to something. Change this to 8. Did anything happen? Change this to 10. Anything happen? Change this to 10. Anything happen? Okay, something happened. Something happened here. So we're going to switch to Team Deathmatch. But it's not putting us in Team Deathmatch. So one of the values we changed. Okay, now we're in Team Deathmatch. Let's change this one to 8. And we're no longer in a Team Deathmatch. So it might be this. This is the only one that stuck when we changed it. Put some more, let's go deathmatch. There's a lot of bots in here. And now we're going to set this to 7. And notice, it changed the state right away. So we know this is the game state. Or whatever setting, whatever game mode. So right now, we also need to find the player counts. So right now, 16 versus 16, that's 30. Let's search for a small number first. Deathmatch, 2 players. There's only 2 players. New scan, search for 2. Change it to 4 players. Make sure there's 4 players. Search for 4. It's one of these values. Search, change it to 32. Okay, it's all of them. Change to 32. Change to 2. Okay, this one only one changed it to. Count. Okay, the next thing we need to find is our health value. We've shown this in previous videos, but show it again. Grab a grenade from here, throw it. First, you want to search for our, and turn off the bots. So first you want to search for 100. Then you want to take some damage, reduce our health. Search for 93. This one value. Okay, that's our health. We need to find a pointer for this. So, pointer scan. Just leave the default settings. So you want to find the lowest offsets. So it's one of these. Could be all of them. Let's keep it open. What I do is close the game and open it. Reattach. Okay, it's all of them. Go to a mode and make sure those other values work. This was our original health. Just delete it. So we know these values work. Change this to 7. Don't change it to a weird number like that. Now we're on team. So we know all these are correct. Change these to health. What we need to do is we need to find the base pointer. So you want to click this, find what writes this address, and close this. What writes this pointer? It's going to bring up this window. Take some damage. Set the bot to idle. I missed. Okay, so we need to find what axis is. This is our value. What axis is this? Because we need to find the offset. That what we found earlier was the address that modifies our health. We don't need that. We need to find the offset. Because like in video games, all the offsets are usually the same. So the offset for our health is going to be the same offset for the enemies. So right now we're seeing that the offset is F8. So health. It's important to know because okay, so there's EBX. So this is the base. Or it's basically these addresses without the offset. So we can just remove this, put a 0, and this is the base address. Set these to hex. So our health is going to be the offset of F8, and like everything in our video game structure is going to be from that offset. So what we're also going to need is we're going to need to download another program. Reclass.net. This will help us. It's called Reclass. There we go, that one. Download this one. It's going to be linked in the description below. I have it installed already. Extract it. This is a lot better than a cheat engine for just visually understanding what we're looking at, like the structure. To launch it this way, I want to launch it as an admin. And take this, attach a process. Okay, we launched it as 64-bit. So that's how we tell whether the game we're trying to hack into is 64-bit or 32-bit. So we got to use this one, because it won't find a Soul Cube, because Soul Cube is 32-bit. Okay, so I found it because it's 32-bit. Attach the process. I'm going to stop this. So here's what we're going to do. We're going to take this. It's like whatever one we want to use. I'm going to use this one because this one I have in my notes. So we're going to copy this. You're going to paste it in this address. You're going to put a bracket around it. Bracket. And put these arrow around AC client. Then you're going to press enter. And basically this means dereference it. So it's going to be pointing. Okay, this. So it's going to be basically. So this address plus this address equals that address, right? So we're right here. But the first address right here, since we put in hex, is going to be this address pointing to this one, because this one's a pointer. We just set it to hex just so we know it's not a value. But okay, so this is going to be our player structure. So what we're going to know is F8 from here is going to be our health. So our health is 52. Because all the structures in the video game, like even the enemies, are going to be their health offset is going to be 58. This is very important because to find the entity list, let's keep adding more bytes. Like all this stuff, like if we move around, we jump, and notice only this number's moving. So this is our player structure. This is just important because it's a lot easier to understand, because cheat engine, here's the thing, cheat engine doesn't give you all this information. See, you have to switch it. You have to go to here, you have to switch to different data type, right? Float to see these values, right? This one automatically guesses, right? Like our health, it gives you your health in multiple values. It gives it into float, into a hex, and it also gives you into an int. So it's able to like predict and guess what the values are. What cheat engine does not do that. So that's why we're using this. It's a lot more convenient. So from here, we want to find our team, because that way we know whether to aim at the dude or not, because we don't want to aim at our own teammates. So how you change your team is you want to go to settings, gameplay settings, and also make sure we are in the team setting, which we are. Go to player, team deathmatch, settings, gameplay. And here it says switch to enemy team, right? But first, what we got to do is we got to do the same thing. New scan, unknown initial value, first scan, right? Let's do it when we're on the team. First scan, unknown initial value, scan. And now we're going to move around. 0 for unchanged, unchanged. Now we're going to switch teams. Now we're going to press 1 for changed. Move around, unchanged, 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 unchanged. Swap teams. 1 for changed, unchanged, 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 unchanged. Swap teams. Change value, unchanged, 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 unchanged. And it should be in this structure, but it's very hard to tell because usually it's going to be 1 or a 0. And there's a bunch of 1 or 0s. Unchanged, unchanged, unchanged. Changed, unchanged, unchanged, unchanged. And it could be one of the green values, but it most likely will be part of our structure. Probably going to be very close to this. Probably going to be one of these values. And is that, so let's narrow it down more because it can't be a huge number, right? So we're going to search a value between 1 and 100. Because it can't, our team, it's either going to be 0 or 1 or 2 or 3. It's going to be a tiny number, right? Okay, so do it again. Change teams. 1, unchanged, unchanged, unchanged. So basically you want to look for this one that is close in this structure. It's going to be like the addresses are going to be close. So only addresses that are close. It's actually only this one. No, these two. Yeah, these are close to our structure. These cannot possibly be it. This is too far away. This one is CE4. C. Add more bytes. Okay, this one. Change team. Okay, this one changed. This one is probably going to be our team. Where's ends? Because it's the only one that's changing. Because this one could be something also. BB0. This could be something, but so we have these two values so far. So we also found our name right there. That'll be important. me swap to something that doesn't have teams. This one's set to 0. This one's set to 1. Do it again. This one's set to 1. Swap to a team. That's set to 0. That's set to 0. Yeah, this is something. I'm going to switch teams. This one's set to 1. This one's set to 1. I mean, this could be something, but this one's the only one that's changing 1 or 0 because there's 2 teams. It's got blue team and red team. So it looks like blue team is 1, red team is 0. But this could be something. We're just going to keep it there just in case. But this is going to be an offset. What we got to know is it's going to be an offset from this. Okay, so we're not going to use these even though they're the same. We're going to use this one. That's our base pointer. No, base address. We're going to press Control C. What'd that do? I just deleted it. Luckily we have it up here. So we're going to Control C, Control V. We'll set the offset of F8 to be our health. And this one, this is the offset CE4. And this is the other reason why we use this because it's pretty easy. So the offset is 1 F8. Copy, Control C, Control V, Control V. Team 1. Just put name in Team 1 and Team 2. So this one's offset of 1 F8. Other one is offset 32C. But only we're going to use one of these in the code. Because one changed to 6 or 7, changed to a huge number. What we also know is 24. Control V, Control C. 224. Change it to a string. Do I have the right address? Okay, it's not that one. Why is it not setting to... Is it because it's going to be one more? Okay, it's going to be one more because there's a dot here, right? So the name actually starts at 1 byte past the dot, so that's why. So these are things to know that we're going to have to remember, these offsets. Okay, also the other thing we need to do is find which one of these is our moving position and our camera position, because we don't want to aim at someone's foot, right? We want to aim at someone's head, so we're going to aim at their the camera position. So we're noticing This value changes when we jump. Control V, Control C, Control C, Control C. And this is a 4. This is a float. Next value is an 8. Float. Next value is a C. Float. We can also do it like this. We also see these values. And notice these values are changing when we're looking. Name them. X, Y, Z, X, Y. So since this is higher, this is our eye, this is our ground position, our foot position. Changes to floats. And okay, this one's 90 when we look down, negative 90 when we look down. So this is our pitch. Yaw. And this offset 40. XI, YI, ZI. I'm going to copy these. And this is offset 34. $38. And 3C. And what we can do is we can lock them. And notice we can't move. So this is our foot. And nothing's going to happen when we modify, like, it's kind of glitching out, right? It's not holding its position, but we know this is our camera position. Okay, so these values, Control C, Control V, Control V. First one's going to be the yaw, pitch. The yaw's offset 40. This is offset 44. And how we can tell is we can lock this and see it doesn't let us look down or up, but we can turn around. When we lock this one, we can't look left or right, but we can look up and down. So we got those. So this is basically what we need for the aimbots. So the enemy structure is going to be exactly the same. So right now we're going to find the enemies. Let's go to a mode where we have enemies. Let's put like a little bit of enemies. It's too many. Let's put 4. And so what you want to do is you want to find one enemy. And since we just loaded the map, we know their health is 100. For a scan, I'm going to shoot them once. And definitely you want to use hotkeys for this also. Settings, hotkey. I have minus for decreased. So now we search decreased, shooting them again, decreased. So this is enemy 1, entity. Then we're going to find another one. We know his health is going to be 100. Shoot him, decreased, shoot him again, decreased. Okay, this is entity 2. So what we're gonna do is we're gonna pointer scan for this. Set the lowest offset. Now we're gonna pointer scan for the next entity. Because not all in different video games, the entity list might be different. So I always scan for 2 entities because they should be like roughly close to each other. The base addresses like is going to be the same, but what we got to do is we want to eliminate a lot of these. So we're just going to close the game and reopen it. Four players. Disable the bots. Let's load again so they didn't shoot each other. Attach. Okay, so the enemy's health should be 100. So what you can do is rescan this memory address. Value should be 100 because they just loaded it and they did not shoot each other. Okay, so this definitely narrowed down a little bit. Do the same thing here. And both these enemies are going to be part of the same entity list. So there should be some commonality between the addresses. So look at the top 2 ones. Like these. I mean, you start one at a time, I guess. So I search for this one. And see the offset's F8 because we know that's their health address. So we're going to add this one to the list. Copy this. We're going to open another reclass. Attach to this. Paste this in here. Do the same thing. Brackets. Add some bytes. All right, so this is how you figure out whether it's an entity list. Let's put some more enemies in here. Let's max it out. And notice it did change, but we're not sure this is the entity list. We are not sure. So what we're going to do is, okay, so we know this is nothing, but this is something. If you hover over it, right, and then you scroll down, we get some information. Like their positions, right? Because we know the first offsets are their position. So this is really easy way. This is why we use Reclass for the entity list also, because it's really convenient. So what you want to do is you want to set this one right here. Right click. Class instance. And then we're going to name this right here. Bot. And we're going to click down. And we're going to name this one info. Okay, and this one, we're going to set it to a pointer. And name this to ent ptr for pointer. I'm going to click this. and set it to class instance. And we're going to name the class instance ent for entity. And then we're going to add 64 bytes. Okay, so this is basically we're hoping this is the first entity in the list. But we did this just to set it up. So we're going to close these arrows over. And then we're going to reset this one by going this, hex 32. And we're going to set this to an array. Change value, an array. And click this one, set to class instance. Click this one to set it to an info. And it just basically, it had it set up like we had it set up. So then we want to change this one right here to 32 because that's how many players are in there. And this is what's super nice about this. Then we can add some bytes. Add some more bytes. Let's add a lot of bytes. And what we know from our initial one, right? Even though it's no longer attached to it. So what's easy is by their name. Where's our name? What offset was our name at? Oh, it's not no longer, but we saved it here. Okay, so our name is going to be offset 225 or it should be 224. So we're going to go down here. Okay, so this is someone's name. Change this. I'm going to set it to 12 because we want it to be not like an offset or just 12 is divisible by 4. That's what we set it. So we have this person's name. Let's maximize it. And then we're going to press this for going to be our first entity, and it's a different dude's name. And we know dude and the other person are in the game. Let's find dude. Dude's the third player. Then you click this over. Kilkenny. Kilkenny is the fourth player in the game. And as you just keep doing this, it's going to be a different person's name. Because that's the only thing that we can verify that is. I mean, they're positioning right, but this could be anything. But we know an entity definitely has a name. His name's Pwned. Where's Pwned? Okay, he's 12. He's number 12 on the list. Let's go all the way to end. See, this one, there's nothing here. Because how many we got on our team? 32 players. Because see, the entity list has 31 players, right? And it starts at 0. Because we're also in the entity list, so it cuts off here. But at 30, the last player is XP. Yep, the last, as you can tell, is the last student in the list, 31. The reason why it says 30 is because it starts out at 0. The first entity is 0, and we are 32. So it's, I guess we can set it to 31. I guess it'll be a little bit better. So the last entity should be this guy. Yeah, it's better because that way, because it's the entity list is 32 players, and we are not in the entity list. Something that people need to know. Some games you will be into entity list, but this game we are not going to be entity list. As you can tell, it starts with 0. So the first player is 0, and then the last player is 31. So total 32. But something to know is that we're not in the entity list. So we found the entity list, and this is right here. This is the address to the entity list. And this this is where we are at. This is the player list, entity list, and this is the bot entity list. So we have found everything we need to write an aimbot right now. And close this stuff off. Minimize this. Close this. This is everything we need to write aimbots. I think I felt like I went a little bit fast explaining the entity list, so I'm just gonna explain it again. Grab this from here. Attach. So basically what the entity list is gonna be is it's an address, right? That so the first entity is nothing, it's 0. So if entity list starts at offset 4, so it's just going to be, it's one address that has a bunch of other addresses. These points to a different entity. So this is nothing right here, but it points to one entity. So let me just change the team. I change the team amount to something smaller. See, it now it like see, they're all exactly the same. It cleared out. It like duplicated or something. But we know this is the entity because we can tell by their the first 3 values. That's something. And this is just basically a duplication of it. It's just how the game runs. If we change this to a different one, 4 players. See, only these change and the rest are duplication and stuff. I guess if you start the game from scratch, it's not going to show anything. It's not going to be filled out. It's going to be basically nothing. Reattach. And now this probably won't show anything because there is no entities. Go to single player, 2 players. And see, it just fills out one entity. So there's one entity, that's him, and you can tell he's moving around and stuff. And then we're going to set it to more players. It just adds more entities. Like there's 4 players, right? And we're not in the entity list. So there's technically only 3 entities, not including us. So this is how it works. This is basically see, this address is a list. There's a bunch of addresses, and these are pointers that point to another value. The reason why we had this this one right here, it just makes more sense of it. Because when you go like this, and then you drop this down, let me. I guess I could have set it the other way. Let's clear this out. Set to hex. And we set this one to class instance. Click on this. Info. You can also do this, right? And then you get all the info around the first entity. His name is blah blah by now. You can also do this, right? Instead of putting an array, you just do this. But this just takes a lot longer. That's why I didn't show you this method. But I'm showing this method because I want to. The entity list is probably the most confusing part about writing Aimbot. So you go here, class instance. I'm basically set all of them class instances because. Okay, so we're on a 4 player. So this can be the last entity. Set a class instance right here, and then you click on this one. And you set it to info. Then we click on something right here. Man, there's a lot. Click on his name. It's going to be also clicked on his name. Let me remove all these. Remove node. And see, it removes the nodes on all the other ones. But let me remove. Nah, that'll make it more confusing. I wish I could make this smaller some, but as you click on this, it just basically tracks it. If I can make this smaller. See, it does this cool thing about being able to track. Like you click on this one, but there's so many open. Then you add this one, class instance right here, set it to info. Open it. You click on this, and it highlights all of them. This is the other way to do it. You click on this, but there's just so many things to the track. Click on the name, and so I click on all the names. So this is the other way of showing the entity list. Let me make it even more simple. Let me remove the name just so we can see a lot more. Right here, remove. So then when we click down this drop down, right, we click on this, it's displaying all of theirs. Because we know this is their eye position. We know this is their foot position. And we know this is what they're looking at. Or we know this is where they're looking. So when we edit this, float, change this to XI. It changes all of them to XI. X, Z, YI, Z, I. It's, yeah, and it saves all that info. So if we add more entities, right, we get more entities, right? And we do the same thing. Here, change instance, click on this to info, click on the drop down, and see more info. We have 1, 2, 3, 4, 5, 6, 7. So I have 8 players total in the match. So this is the other thing. This is the other visual way of seeing the entity list. If you don't do the array thing I showed earlier. But yeah, this is one of the most confusing parts of it. Not the confusing, most difficult part, because finding the entity list is very important to like have targets, you know. This is how we get our targets and we organize it from here. Okay, so now we're going on the code. Can't, it's hard to minimize. Open up Visual. Empty project. Next. Set it to x86. Add the source. C++. First thing to add is our includes. Now we're going to add our variables. This is the stuff, all the stuff that we found. So we found, okay, so we're going to use numberpad 9 to toggle our debug info. We're going to use F6. These are basically the documentation here, the virtual codes. I mean, you can set it to whatever you want. So basically, this hex number means, you know, like the keys, the number pad, the F keys, whatever you want. But we're using number pad 9, F6, and right mouse. Okay, so we need pi for our calculation, for angle calculation. This is we're going to toggle our debug menu. It's very important for your cheats to have debug, so that way you can fix bugs and stuff. Okay, so this is going to be our process ID. I'm going to explain this more later on. This is explained in previous videos also. This is our base address for AC client. We're just gonna initialize it to 0 right now. We need this, the handle to our process, initialize it to 0. This is the number of entities, initialize it 0. Okay, so our player base, as we found earlier. So we have this. This is our player base. We found our player base by let me reattach. So we found our player base by shooting the target, right? And then our health is going to be offset of that. So this is how we found our player base. It's going to be this number. So we set it there. So the entity base, we found it by shooting the two entities. And then we found did I still leave that open, or did I close it? I guess I closed the windows. But we found this by shooting one entity and then comparing them. If whatever because the entities are going to be part of the same list. So both these enemies had this address in common. So that's why we're using it. Because all the entities are going to be part of the same list. It's going to be one address, right? That's going to be pointing to multiple entities. It's going to be one after the other. So the more we add, the more this list will fill out. Okay, so entity loop distance, how we figured this one out is that we notice the entities, there's no entity at 0, so it skips that, but they're 4 bytes away. So entity 1 is at 4, entity 2 is at 8, so 4 plus 4 is 8, and then hex, another 4 you add a C, and then after you add 4 to C is 10, and so on. So that's the entity loop distance. The player count, we found that one of the first things we did, we found it by just changing the players in the game and then searching for that. The game state, okay, so in our code we're using this one. I remember there's multiple. Let's add this one to this and see what it is. Yeah, they're the same value. One is probably just visual. So if I'm pretty sure the one we're using in our code, this one, the 44, nothing happens when we change it. When we change it to 7, nothing happened. When we change this one to 7, it's gonna put out a different team. I mean, basically the same thing. Now we're switching to deathmatch. Both of them should switch to 8. So it's like one is a visual number and one is changing. So I guess we're going to use, since we found this in the video, we're going to use this one. So this is the one that changes. Ideally, you don't want to use something that changes in the video game because your code might accidentally change it, but I don't think anything's going to happen. But let me make a note. Hold on, let me make a note. We'll just duplicate it. But since we found this in the tutorial, we're going to use this one. Okay, our eye position. So basically, what does that mean, our eye position offset? So it starts, well, the entity list, as we know, from the entity list or the enemy list, I mean, our player list or the entity list, it first starts with the offset of 4. That's why it was here. And the rotation, let me reattach one of these. Okay, so rotation starts at offset 40. So that's why we have that. So it starts with the yaw and then pitch. Our health, F8. This is not just for us. This is for everything in the game. It's a lot simpler to have everything exactly the same. All the offsets the same. F8, right? 100. Okay, our name is 225. It says 224, but we're not counting the first byte, which is a period. So 225 starts with C, and the team is 32C. So we found this one correctly in the tutorial, but we also found this one. So this one could be something, but we only need one. But we're going to also note that is something. Team other. I have so many windows open. Team other, it's 1F8. First thing we're going to add in here is get process identifier. All video games have a process ID. So this is basically what it does. You open Task Manager, go here, Task Manager, Details, AC Client. AC Client has a PID 3116. This is the PID. This is how we find it. I mean, you can manually type this in, but it's better to have some code to automatically find this every time you launch it. So this is what it does. Don't need to know what every line of code does. You just got to know what the function does. And this function, you input the exe name, acclient.exe, and it gets this number. It's very important how the hack starts. So get the process ID. Oh, hold up, my head's definitely going to be blocking some of this code. All right, so my head's not blocking it. So this is the process ID. Let's close it. Next thing you need is the module base address. Okay, so this is what the module base address is. If you're going to cheat engine, go to memory, right here. Like everything, all the DLLs, this will be, depending on the video game you use, this will be an EXE or a DLL. So AC Client doesn't have EXEs. It doesn't have DLL. It's just an EXE. So the start of it is 400,000. So this is the module base address. So this is basically where the video game starts in the memory. So if you had a DLL or something, it will start somewhere else. It just finds this line of code, finds that using this function. So automatically will find this. Some video games change all the time. Assault Cube doesn't change. So that's basically what this does. Okay, the first thing we're going to add is our structure. This basically collects all the info we need. This is our player structure. This is us, not the entities. Entities is going to be something else. But basically, it stores. This is a container, so it contains all this stuff within this structure. So this stuff is going to be only accessible by the player structure. So it reads the addresses. So what it does is so it does a read process memory. This this explained in the previous tutorials and in detail how this works and stuff. But basically it reads the this, which we explained earlier, is this plus AC client and stores it here. And then everything is going to be an offset of the local player, as we know from reverse engineering it. Not this one. Not that one. But as we know, everything is offset off the local player. So everything's offset here. So that's basically what it does. It just reads the memory with all these addresses. So it gets the team we are on. It gets our health. It gets our eye position. It gets our name. It gets the player count. And what it does, it subtracts 1 from the player count because the player is not in the entity list. And it reads the game state. So that's basically what this structure does. Okay, now we're getting into the aimbot code. So first, you want to have a debug. When you're testing your code, there's a lot here, and there's a lot to explain. So you want to have a debug calculate angle. This is not the one we're using in our hack because we had to learn that our code works. So basically, this is going to be reading from the player. It uses this player structure, it reads all this information. And it does all the math. I'm going to explain this in detail, but this is yeah, we're going to start little by little. Okay, so let's go inside the video game to explain what's going on. Cannot move the window. And here's something cool you can do. Which one is it? It's one of these. You're going to set it to 0. So then the bots stop attacking and everything. Okay, so what we want to do is this is what we're going to be learning the aimbot. Press E and you can fly with spacebar. So we're going to be aiming at this. So we're standing right on top of it. And our address is, we don't want to use our eye position. We want to use our foot position. So it's about 119, 132, 10. So basically that's what this address is going to be. This is more precise, 132 and 11.5. This is basically where the health pack is. This is very important because we're going to be debugging our aimbot. We're going to make sure the aimbot works. So first we're going to explain everything line by line. So basically this is what this is our first enemy. Our first enemy is going to be the health pack. And we're going to initialize our angles to 0. This is important. We always initialize stuff. And so the first thing is you got to calculate the distance XYZ coordinates between the target and the player. This will give it our absolute position as if the player is at 0, 0, 0. Okay, this is where we're getting into the math part of the aimbot. Let me see if I can find the graph. I think it's this one. Okay, there we go. Okay, so basically, let's move our player somewhere in the world. So basically, we know this address, blah, 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 blah. 120, 132, 11.5 is our health pack address. So we're going to be aiming at this. We're going to stand right here, and we know our health is a little bit higher, and it's over there on the map. So we're gonna first plot this, because it's very important to visually understand this. I'm gonna close this stuff off. We want to visually see this stuff on the map. This is what the video game map is gonna look like. Video game world. You have the X, Y, and Z is up and down. So we're first gonna put that in there. 120, 132, 11.5. Okay, so it's beyond this. So we're gonna scroll our mouse wheel back. Okay, so this is basically where the health pack is. just a good representation in the video game world where it's going to be. So it's over there, and we're going to be standing. We'll be standing next to it. So where we are standing, we are standing at. We're going to use our feet position. These are our feet position. 143, comma 114, comma 0. This is where we're standing. So we're standing here, and the health pack is over there. It kind of looks like this, right? The health pack is a little bit higher than us, right? And it's to our left. So this is a good representation of where the health pack is in the world. We're not at 0, 0. We're somewhere off in the map, right? So what we're doing here, let me get a paint. Oh, don't need paint just yet. So let's get sticky notes. Okay, so what we know is, I'm going to copy this. Targets, or health pack, equals 120 X, 132 Y, 11.5 Z. Player equals 143 X, 114 Y, 0 Z. So here's what this line of code is going to do. This line of code right here basically does the enemy X minus the player X. And then enemy Y minus, that's a typo. So enemy Y minus player Y, enemy Z, and then it's going to store it in delta. So let's, when you're writing anything, when you're writing any program, especially a cheat, you should be able to do the entire cheat, manually calculate everything. So let me just verify these addresses are correct. 0, we got to double check before we even start doing things. This is 120, 134. All right, so we're going to subtract our enemy, 120, minus us, 143. So delta X equals negative. Let me just make sure. Enemy, us, that's correct. 132 minus 114. Delta Y equals 18. Double check. 32 minus 114. And then 115 minus 0. So delta Z equals 115. This is very important because it's going to move everything as if we are at 0. This is very important because this graph right here is going to be very difficult to calculate anything. So what we're going to do is we're going to be at 0, 0 now. So, but we're going to put these notes. Negative 23, comma, 18, comma, 115. And we are at 0, 0, comma, 0, comma, 0. So that's us. And if you look over, it's basically, we just moved everything. They're exactly the same distance, right? But we just move them over. we took it from here and moved it over to there. So it's basically, because we can't do the math from here. If we did the math from here, it'd be a lot more harder. Maybe it will be easier, but I don't know. It'll be a lot more difficult. But the way we set up our math is that we're doing, our player's going to be at 0, 0, and the enemy's going to be there. And if we look at, it's basically the same thing, right? They're exactly the same distance away. Exactly the same distance. We just basically normalized it, or absolute 0. They're the same distance. If you take your finger, right, and just like, they're this far away, and then that's so far away. That's basically what we did. That's what that math equation did. So we no longer need this. We just hide this. So basically, this is all we got to know about, right? We're standing here, and the health pack is over there. See, it looks like the in-game footage. We are here. Health pack is over there to our left, and it's a little bit higher. The reason why we do this, let me set it. Okay, this is the correct way. We're gonna first set it up like this, right? Because the video game has two things. We have the yaw left and right. So first we're gonna do that, and this is why we need paint. So we're gonna take a picture of this with the snipping tool. Copy. Paste. Okay, so we are here, and we want to draw a triangle. So we draw a triangle. Okay, because what we know is using the very next line of code. So we're done with this. We got these values. And next is we need the Pythagorean theorem to find the hypotenuse, which is going to be it's going to be this. But I'm going to label this stuff. Close this. Okay, so what we know from our notes. Okay, so this is the y. Y is going to be 18, as you can tell by the graph. Y. And this is the x, which is negative 23. Negative 23 x. So how we find this part, h, hypotenuse, is we okay, so this uses the delta also. So we're not going to use the delta because this is in 3D. I mean, for this example, for the calculation in the video game, you do need this, but if there's no way we're going to calculate it in the 2D space, because it's right now we're just calculating one angle. And on top of it, we don't use the hypotenuse is only used in the up and down. So what we know is delta 23 squared, or it's negative 23 negative squared plus 18 squared square root let's do it again. 23 squared 23 squared plus 18 squared equals, and the square root of that. So this is the distance of the hypotenuse. Probably don't need all those digits. Let's put 6h. Because that way we're going to find the angle. It's very important. So there's multiple ways to find angle. These are it. Arc, tangent, arc sine, arc cosine. So we're going to do all those because it's very important. Because the video game you might work on might have a different, might work something better. Okay, so first we're going to find the arc sine, which is going to be the opposite. Okay, let me label these also. So this one's opposite. Oh, come on. This is the adjacent. So how you find that is, so yeah, but in our code we're going to be using ATAN2, but we're going to do all the math. We're going to do ATAN1, ATAN2. So this is for ATAN. So it's going to be 18 divided by this. Eighteen is opposite, divided by adjacent. Equals this. So just enter this number, an entire number. Then double check our math. It's opposite 18 divided by adjacent, negative 23. So this is going to be our arctangent. So it's negative 38, or that's, let's write it down here. So we're going to also find the arc sine. I mean, we're using one, but just for demo purposes, we're going to show all of them. Opposite divided by hypotenuse. $18 divided by 29.20616. And make sure 18 divided by that, arc sine. So this is the arc sine. All these ads, man. Arc cosine. Which is going to be adjacent, which is this one, divided by hypotenuse, 23 negative, divided by 29.2061. Let's see, we get different addresses on all of them. And we're going to also do the one we're using, A102, which is going to be the same thing, but A102 is more advanced than A10 because it doesn't divide. I think I use this one. Okay, this one. So see, it uses the X and the Y. You got to know which one is the X and Y. So X is negative 23, Y is 18. This is A102 calculator. It's completely different. So the value we get, so we get a completely different value. Because this one doesn't work in all quadrants. This one does. And we're gonna debug the code and everything. So yeah, every address we got is different. We got inverts our cosine, basically the same addresses. These are basically the same, but one's negative, one's positive. Did we screw something up in our math? Let's check again. Arctangent. Negative 23 divided by, I want to double check this one. It's always good to double check your work. Opposite 18 divided by 23. Yeah, it's correct. Okay. Double check this one just in case. Opposite 18 divided by 29.2061. 61. Yeah, they look good. All right. Always double check your math. Because the values, as we could tell, we're using different functions, and two functions we get the same result, and the other two functions we get the same result, but they're negative. But we're going to try all these in our code. Let's comment this stuff out. That's the rest of the code. So first we're going to be testing. We're going to be testing our A10 function. Okay, so what's going on? Okay, a Sol cube. Why do we have this? Convert radians to degrees. A Sol cube, our yaw and pitch is in the degrees. One let me just show you. Okay, so if you're looking up, it's 90. Looking down, it's negative 90. If you're looking here, it's gonna be like 0. It's gonna be close to 0, right? If you look a little bit, it's 360. So the range is 0 and 360 while you're spinning, and negative 90 and 90 when negative 90 and 90 when you're looking up and down. That's degrees, because when you do a full spin, it's 360 degrees. Some video games use radians, some video games use degrees, but the answer, the program gives us our answer in radians. Like the programs that we use online, they give us, two numbers. It gives you radian and degrees. You enter this and it gives you both. But the C++ program will give you the answer in radians. So this is how you convert radians to degrees. It's 180 divided by pi, multiply that answer. So this is just a conversion, just so people can follow along. Okay, so first we're going to do the atan. And we're going to run this code. I mean, basically, this is it. The aimbot is just this simple code. So we're, oh yeah, we got to paste the main loop. So we got to paste our main loop right now. And let me explain what the main loop's doing. It first gets the process ID, gets this 3116 from this exe, assault AC client.exe, and then gets a base module address using the process ID. And that if a video game had a DLL, you put the DLL in here, but AC client has no DLLs. It's just AC client.exe from that. So it gets this address. And we're going to also debug it to step it through. Then opens a process. It's very important from the PID because we need access to open it. And then we have I told you what the aimbot does, and then it sets a foreground, so it sets the window, and then it just runs our code. It runs our debug calculate angle, which is right here. So we're going to step through this code, put a breakpoint here. Is it running? Okay, so first thing, I'm going to step into it. Don't need to run every line of code. So we know that's correct. So we know that's correct. 3116. Let's step over this, so we don't need to step into it. And it's in hex. I mean, now it's in hex, 400,000, as we know from here. So we know that. So basically, that's all that line of code does, but we're going to change it back to decimal. And this opens the handle. And we don't need to step through that because it just basically does it automatically. So when we launch this, it's going to set the window to focus. And see, it's doing this weird thing. I think also... Yeah, there's something else here. See, it's like, it's aiming here. Why is it aiming here? Oh, and it's writing. I didn't explain everything else, what's going on here. Okay, so we need this. This is our debug info. It just prints it. It prints our delta, delta x, delta y, prints our hypotenuse, it prints our angles, and it prints our position. But what I'm doing here is I'm writing both to x and y. We want to just write to our first angle. That's why I wasn't able to move. So when we notice, we're going to move up and down, but we notice we're pointing here. But the thing is right here. It's basically, okay, this is a full turn, right? This is a full turn, and this is a half a turn. A full turn, this is a half a turn. This is a quarter turn. A full turn will be this, right? A full turn is 360. A half a turn is 180. A quarter turn is 90. So notice we're aiming at this direction for some reason. So it's not correct. Could be our code, but I should have also, you can also do that here. You can plot this. So basically what we're doing is all these are to find this. When we use those calculations, not that. So all of it is just to find this angle. We know this angle is 90 degrees, and we're using this. We're using arcsine, arctangent, arcsine, arccosine to find this angle, right? So this gives us the angle negative 38, 30, 114, and 114. I mean 141. So right now, what it's giving us when we run the program, so the angle that it's giving us, so it's writing negative 48 because we're currently using the tangent, and what we already did the math. Okay, hold up. Why is it writing that? Oh, did we move? We moved. That's why. Okay. Here's how we can fix this. It's writing a different value. So we're gonna lock these. This is not our eye, this is our foot. So it's using, because we've moved. We're doing our calculation from this. So let's go back here. 114. All right, and notice that it's back to what we were supposed to calculate it. I should have locked this because I shot my gun a few times and it caused my dude to move back. But so far we got this calculation, negative 38, and if we go back in the video game, yeah, it's still half a turn to the left, basically 90 degrees. But this could be multiple things, right? Let's also use. We're gonna use the next one, arcsine. And now it's looking at this direction. So it's looking 180. It's like we're facing this way and it's behind us. Okay, so that's interesting to note. And the address we're getting is 336. Why is this slightly different? Oh, because we're using that's why. Because this hypotenuse was calculated. Let's change this. We're calculating right now, just for the example, we're calculating this flat. So it calculates 38. But in the video games, in the 3D world, that's how we have this, is because it's a 3D world. But right now, since we're just demonstrating on the flat, we're removing this. But in the final code, we're going to add that back because it's important, because it's a 3D video game, not a flat video game. But our calculation is from a flat, a 2D video game. It's very important to know. But since which one is it? Okay, so we know it's behind us. It should be behind us for this calculation. And then we have another one, cosine. A cosine, this was 90 degrees off also. So this one's 80 degrees off. Arcsine is 180 degrees off. Arctangent is 90 degrees off. So this is what you find through reverse engineering. So then you have to add 90 degrees to it. So let's see what happens when we add 90 degrees to cosine. It's looking correctly the direction we are. Okay. So now let's try the other one, the arcsine. Okay, where is it? Okay, this is 90 degrees off. A10. Okay, this one's off. Okay, this is very important to know from reverse engineering. We're going to unlock our position. And we're going to walk around. And see, it correctly aims in this. When our delta, if you look at our delta is 10, right? But once our delta goes below 0, it no longer, it aims incorrectly. So once we're on this side of the map, this is why we don't use ATAN. We use ATAN 2 because ATAN 2 doesn't have this issue. But this is all the stuff you learn through reverse engineering. So see, it correctly aims at the health pack when we are on this side of the map. But as soon as we cross over, let me get the debug. As soon as our delta is negative, you know, let me move over here. Our delta is positive, it correctly aims at it. But once our delta becomes negative, right? See, it aims the wrong direction. So that's something you find out. That's why we're not using ATAN. But if we use ATAN 2, no matter where we at, see, it's constantly aiming the correct position. So it's aiming correctly at the direction that we want to be looking at. So we know ATAN 2 works correctly in this. And another one worked. I forgot which one worked. Was it, okay, so we're not using ATAN 2. Is it ACE? Is it arc sign? Did that one work too? Because you could have multiple ones. Okay, this one's definitely not working. Okay, see, it works here, okay? When our delta is positive, it's correctly aiming, right? But once our delta goes negative, it does this weird thing. It's no longer aiming where we should be aiming. It's doing this weird thing. So now it aims correctly. So, I mean, we can attempt to do the same thing to add some coordinates. Like there was you can do this fix. Like we can fix ATAN by adding this. So we add 180, but this is more lines of code. So this should fix ATAN to always work. So no matter where we're at, right? ATAN is going to correctly work. But they're just, I feel like this is just more lines of code to just do something simple when one function does it. So see, no matter where we're at, ATAN 1 works correctly. But I don't want to use ATAN 1. Might as well just use ATAN 2 because it's less code. So I just have that in there because some people might want to, you know, use ATAN 1 for some reason. So what we know is ATAN 1, you need to have this fix in there. That if delta is less than 0, it adds 180. That's how you fix it. So we know, let's go down the list. A sign. What's wrong with the A sign? Oh, I have all the notes right here too. See, it's wrong. A sign works when delta is positive, but does not work when delta is negative, and it aims this weird direction. So we're going to attempt to fix A sign to work, but why should we when we know ATAN 2 works? So this one doesn't work. As delta x gets closer to 0, it becomes less accurate and drifts away. We don't want that. And a cosine is just not accurate at all. See, it's just not, well, it is, okay. It's accurate right now. But we're going to do more testing. So we know this one kind of works. But I have a reason why I wrote not accurate at all. But that's further into testing. So we're going to keep this one out here just so we know the difference. Like this one works. But we're going to use ATAN 2. It's very important because we're going to add another angle. We're going to add the horizontal. And the horizontal we're going to have to calculate. I mean, we don't have to, but it's going to be less accurate in the 3D game. Like when you're drawing it on here, right? Since there is no Y, I mean, there is no X, we have, let me show you the thing. See, we're just using Y and X. We're not including the third dimension. So that's why we didn't calculate it here. Okay, so we know Works. Hold up, hold up. Hold up, hold up, hold up, hold up. Why wasn't this working again? Let me try this one again. A cosine. Oh, I see it doesn't work. That's why. I didn't spin all the way. So see, it's not accurate on here. It's accurate when delta is negative or delta. No, this is accurate when delta y is positive. Okay, so it stops being accurate when delta y. Let me write that note. Is delta y is what? Delta y is less than 0. Okay, so that's why we're not using that one. So we're going to just use, I knew I did a little more testing than that. So that's why we're going to use a tan 2. Because no matter where we go, a tan 2 is going to be accurate. So no matter where we go, it's correctly pointing here. So that's why we're using that. Okay, so that's the math behind this. Because, okay, so this is the yaw. The next thing we got to calculate, open another paint. Okay, so we calculated this, the left-right turning. The next we got to calculate is the up and down. So we're going to also draw a triangle. Okay, and so what we know, hold up, this is the z, okay. 11.5 z. And this is opposite. And what's this? This is the x. Okay, 23x. Is that the x? Gotta make sure. Yes, that's the next. Negative 23. Okay. And what was the hypotenuse again? Oh, good. Thought I messed it up. Okay, so this is the up and down angle. So we're going to do exactly the same thing. We're going to calculate all these again. because it's very important, because depending on what video game you test on, you might use one over the other. I see some video games, they're only using Arctan. They're using Arctan for both, and they're just not accurate. Their aimbots are just not accurate. So this is why this reverse engineering is very important, because that way your aimbots can be very accurate. It's what's going to happen is if they're too high, it just will not aim at them, or if they're something is weird going to happen. And it's important for you to test what are you going to use in your video game. So let's opposite 11.5 divided by 23 minus, and make sure opposite is 11 divided by adjacent 23 goes 0.5, and negative 0.5. And that's why we draw the triangle, so we can figure out how to do the math. $11.5 divided by 29.20, 616. And to have it maximum accuracy, you want to copy it. Arc sign. Let me just double check it again. Opposite divided by hypotenuse, 0.5, okay. Adjacent, 23 minus divided by 29.20616. Let me double check it before I do it first. So adjacent, negative 23 divided by hypotenuse. And this one's gonna be a little more confusing because we're not using this one. This one says X, but we know the calculation is gonna be delta Y. That's the thing. It's a little bit confusing because we're not using X's here. We're using let me. Okay, so it's Y divided. Okay, so we're just gonna copy this. So it's Z. The X is the same, so they're just flipped. So the adjacent is the same. We're just using a different one. Okay, cool. That helps us. So this is the same. So we're gonna, for the Y, we're gonna put 18. Or no, for the 11.5. There we go. Okay, so this is what we got so far. Let's save it. And again, yet again, we're calculating this angle. So we got a bunch of different numbers. We got negative 26, 23, 141. Why they're all different? That is crazy. Is our math correct? Opposite. Oh, I'm double checking now. Opposite divided by hypotenuse is. That's crazy. All of them are so different. I should have wrote the result, man. Damn it. Because now I can't really. Well, I'm gonna double check this again. Want to make sure these values are correct. All right, I double checked everything and everything's correct. I was wondering why the numbers are so different, but the math is correct. Usually some of them are supposed to be very close to each other, but this is what we got so far. Because if you look at it, this looks like a 23-degree angle. It looks like a 26-degree angle. It does not look like a 141-degree angle, and it does not look like a 153-degree angle. That's why it's kind of weird. Because this one, okay, so this is 90, and this plus this have to equal 90 also. Because a triangle, all of them together is 180. So that's why it doesn't look like it's one of these. But now we're gonna put this in. We're gonna run this into the video game. We're gonna first use arc sine. So it's delta divided by hypotenuse. So, but just so we know, we're not using the 3D dimension yet because just for the graph sake, because I don't know how to do the math using 3D. We're using that. So for the graph to be accurate, for this 2D drawing to be accurate, just so people follow along, you have to add this, and we will change this again later. But just to follow along. So now we're going to run the code and see what happens. A sine. Hold up. Oh, that's why it's not doing that. Okay, so right now we're just writing the yaw. I'm going to change this back. And this writes both of them. Writes both the yaw and pitch. And as you notice, hold up, it's not writing, what the hell? It's writing, what's it writing for the, hold up. Yeah, it's not writing anything for the up and down. Why is this? This is interesting. Oh, because we didn't convert it to radians. Okay, that's why. This always needs to be done because we were writing the we are writing the radians. We weren't converting it to degrees. Now it should work. As you notice, no matter where we go, it's going to be looking at the health pack. Let's fly. It's a little bit delayed. As you can tell, it's not snapping correctly because we're debugging. When we're writing this debug, it does this. But notice it's fairly accurate. And whoa. Shouldn't have done that. Wait, okay, yeah. Let's turn it off. That's because we're not calculating. the the Z, by the way. There we go. Let me put them back to not attacking. And see, right now it's working perfectly fine. But the other thing is we have to test the other ones. So we know this one works. Let's try the A-tan 2. Okay, A-tan 2 works. So we know, okay, both these work. A sign. Okay, let's see A-tan 1. Does A-tan 1 work? Okay, looks like A-tan 1 works. See, a bunch of them work. Okay, and does cosine work? Okay, cosine doesn't. Cosine's giving us this weird thing. But, oh yeah, also, what we didn't do, we didn't verify our math. And our math, oh yeah, our math is being calculated when we're standing in that one position. So let's go back to that one position and verify our math. Okay, we were supposed to be standing. Did I close it? One 43, 114, and what, 0? Okay, now we're going to verify our math. Okay, so cosine. Okay, cosine's giving us what weird angle? It's writing 114, which our math is correct. It is writing not 114, 141. So notice cosine is just terribly inaccurate. So we know our math is right. A-tan 1. Let's see what A-tan 1. It's writing very interesting. It's writing a completely different. It's writing 13. The value we got. Yeah, it's a very interesting. Why is it so different? Oh, because it's. That's a very interesting. Why is it completely different than what we did? Opposite divided by adjacent. This divided by that was that. Yeah, it's correct. Our math is correct, but why is it such a different number? Yeah, our math is correct. Arctangent. This is very interesting. Our results, see, when the game gives us a completely different result, our hypotenuse. Oh, the game's hypotenuse. No, game's hypotenuse is correct. Our delta's what? Why is it giving a 7? Why is delta being a 7? It shouldn't. that shouldn't. It should be 11.5 minus 0 is 11.5. Why is it saying the delta is 7? Oh, oh my God. It's using our I coordinates. Our I coordinates are a little bit higher. That's why. We're using our foot coordinates. This is not our I. Our I is 4.5. Yes. The math was correct. It should be. This is why you got to double check your math, because we're calculating our foot coordinates, and that is wrong. So our actual I is 4.5, which is 11.5 minus 4.5 equals 7. So this one we're choosing this one should be 7. So that's why this one's slightly off. Or the A10 calc. No, which one? Yeah, the A10. 7 divided by 23 minus. Actually, our math is correct. Just what we plugged in was so 16. So it should be. So that's why it's giving us. Or what? Why does this one say hypotenuse? But is it accurate? It is accurate though. Why do I have this? It's interesting. It works with the hypotenuse. Okay, that's interesting. You can put a different value in here because it's supposed to be opposite over adjacent, but if you put the hypotenuse in there, it works. So this is very interesting. That is very interesting for here. Okay, so that works. Let's try the cosine. This one's totally wrong. So both these atans work. So the atans work and this one works. See, this one works too. But let me remove this debug, because this one we can test it a lot more accurate. So we're gonna have okay, so we're gonna use this one, use atan for here, and then arcsine here. And I'm gonna show you why I mean it's accurate. Oh, let me unfreeze my coordinates. As you can tell, see, it does a little bit of a drift. That's because we're still using 2D coordinates. A lot of aimbots don't take into this in consideration. They're still using 2D coordinates. Now we're switching to 3D coordinates for hypotenuse. And now look how accurate it's going to be. It's going to be always accurate. See, it's constantly aiming no matter where we're standing. See, even when we're underneath it, it doesn't glitch out. Remember last time when we went underneath it or went too high, it glitched out. Like our character just went like blank. And see, it's always aiming at the cross. So we know this one's extremely accurate. Okay, so we know this one's extremely accurate, but we want to test the other one, the atan 2F. Because this is what most hacks use. Most hacks use atan 2F for both of them. I noticed that. They use it for both. And here's why it's not that accurate. See, as you go higher, it doesn't become accurate. It's accurate low when you're like at like low levels. But if you get close right here, it's hard to tell, but it's easier to tell when you're flying. See, it's accurate here. But once you go higher, it's not accurate anymore. So a lot of hacks use atan 2 for both. I don't know why, but it's not as accurate. Like if you're playing a video game and you're aiming at an aircraft, using atan 2 for both is not going to be accurate. This is why I showed you all of them. So the most accurate for the yaw is use atan 2, and then use for the pitch arcsine, because this is going to be accurate forever. No matter how far away you go, you know, how high you go, how low you go, it's going to always be pointing at it. See this? It's perfectly accurate. And there's a lot explained. So that's why I went to explain all of them. Yeah, so you can mess around in your hack which one you want to use, but this is why you use this. So you're gonna, for the yaw, you're gonna use atan 2. For the pitch, you're gonna use arcsine. And this you're gonna definitely want debug info. And this is the math and everything. This is all extra stuff. Just commented. I'm gonna leave this in here. But that is basically the aimbot. Now we're getting into the entity list part. So now let's go into, hopefully that wasn't overwhelming. Because right now, just an example, we switch back to when you're calculating all this is x squared, y squared, z squared. This gives you in 3D, but since we're drawing this, we only use those two to get a correct like. But if you don't do this, if you don't have the delta z, it's going to be inaccurate, like I'm going to show you. we're not going to calculate delta Z. And I'm going to show you how inaccurate it becomes. See, it's accurate kind of, but as you fly away, see, it drifts, right? Because you're not calculating the delta Z. It's good for like certain games that, but if you get too close to it, right, it's drifting up, right? As you can tell, it's drifting up. It's not accurate. So like most video games, everything's flat. But let's say someone's like way above you, like way up there. There's no way you can hit them because it's gonna drift. But when you're demonstrating it, it'll be. I don't think how it'll be impossible for me to draw, you know, a 2D diagram using 3D coordinates. It'll be impossible because we're not using the third one. But very important to know, that was just for the tutorial. But when you're going to use your hack, you're going to do all the coordinates. X squared, Y squared, Z squared. Because right now, it's perfectly accurate. There's no drift. It always aims at the cross. No matter where you are, it will correctly aim at it, and there's going to be no drift. It's very important to note. And that's why you have a debug. This is the debug calculate angle. Now we're going to be working with the non-debug calculate angle. And this is what the non-debug calculate angle looks like. We're going to close this off because we're not going to use it. But you're going to use this, the debug calculate angle, for your own video game. Like you first have to debug it first. But this is the non-debug one. Let me explain this. It's basically the same. What the hell? All right, so it's basically the same stuff. What we removed this because we're going to be using that inside the entity list. We removed this because we have no static target, and we removed this because we're going to get our angles from somewhere else. So, and we're no longer writing. So we just removed a few things. We're calculating this, our delta, calculate our hypotenuse. Bunch of info here, right? We're using atan2, convert it to radians. We're adding 90 because that's what the video game requires. All video games are going to have a different offset that you're going to add here. Doing the arc sign, and then we're converting to degrees. So this is what the non-debug is. A lot less stuff in it, but when you're first learning this, you got to have your own debug version because this one only works. Because see the debug one, there's no parameters you input. While this one, you get the parameters from outside. You get the enemy from here, and then you're outputting angles. So inputs player, input enemy, then your output is going to be the angles. Here, everything happens within the function. And here's the next thing we're going to do is our target list. This video is pretty long, I know. It's the most detailed aimbot tutorial on the internet. And if you're still following along, make sure you hit the like. This is a very long video. Okay, so basically the target list is, let me close this off. Target list is basically the same thing as our player list. Or no, it's not. The next one is. The entity list is the same as the player list. But the target list is basically gets it from, like all this information is going to be, should I had it? I should have placed this one first. Copy. Let me paste this one first. Okay, the entity list. The entity list is a lot like our player list, right? It's collecting the data from the entity base. It's this one, stuff that we talked about earlier. And an entity loop distance. Oh yeah, this one's a little more to explain, right? Okay, so you have to initialize it. It finds out what team they're on, their health, their position, what aimbot angle for each player, and then the name, and then it reads the entity and has an entity of a variable that you can put in because adjust the index since list starts at offset 4. So you got to increment this by 1. It first starts with a 0. This increments it by 1 because what we remembered is the entity list, right? The first entry is 0. So we have to increment it by 1. So when you do the math, it's going to be, this will normally be 0. 0 times 4 is going to be 0. But this is going to be 1 times 4, which is going to be 4. So it's going to first start. Where is it? So it's going to first start here. So this basically, this line of code right here skips this. That's basically what it does. Adjust the index since list starts at an offset of 4 right here. It depends. Your video game, the entity list might start here, and then you just don't use this line. Or your entity list might start 8. You know, let's say if it starts at 8, you're going to have to do that twice. You're going to have to do this. You have to do that twice. And then it starts, and then that's how you'll get to starting there. But since we're starting at 4, we have to do it only once. Or it also depends on the entity loop distance, right? Like let's say your video game has entities 8 away. You have to have this one to an 8 instead of 4. So it just depends on how your video game is. Okay, so it collects the team, what team the entity's on, the health, their eye position, and their name. So this is what it does. Okay, so the target list basically takes from the entity list and adds all this stuff in. Like we're going to need to know the distance. We're going to need to know the angles, their name, this stuff. So this basically converts the entity list into a target list by collecting all this stuff. And this stuff is more within the Aimbot function, which is going to be introduced right now. Okay, and this is the Aimbot function. There's a lot going on here. Okay, so first, it reads the memory like what we had in our debug. First thing we do is read the memory from the player info, because what we need to know is we need to get the number of entities and the player position. So we got to get all that information. So this creates dynamically allocates memory for target list and entity list. So this is a raw pointer, an array, using new delete after using to prevent memory leaks. We do that correctly. And this is a smart pointer. I wanted to use both of my smart pointer, but I couldn't figure out how to get this one to work with a smart pointer. Ideally, you want to be using smart pointers than using a raw pointer. But the only way I got this, there's a part of this where it has to sort them from the closest to furthest away, and I couldn't get it to work without using a raw pointer. And this is just some complicated stuff, but yeah, so it creates based on how many entities we have. Right now, we're gonna have player count 8, so this is gonna be 8, and the target loop knowing the size of the target loop. So then it iterates to all entities to find valid targets, right? It uses the entity list, which is this. So it first puts a 0 in here, increments it by 1 because the first entity is at offset of 4. It reads all the data, right? And this line of code right here, it checks to see if they're dead. So if their health is less than 0, they're dead, and it continues. And this is where here, this checks what team they're on. So 0 means you load it into the game from fresh launch. 7 means it's a team deathmatch. 8, deathmatch. 12 is one-shot kill. 18 is pistol. 19 is use daggers. 20 is a team survivor. 21 is team one-shot kill. 7 is survivor. So basically, if it's a 7, so if it's 7 survival, 20 team survivor, or 21, which I mean 7 is team deathmatch. So basically, if these are teams, it won't aim at your teammates. So this basically all this line of code is, it doesn't aim at your teammates. And then it calculates the angle. Basically, all that math we did earlier. It does calculate the angle to find out for each entity. So all the entities are going to be calculated their angle in real time. All of them always. And then it adds them to the target list. All this info. and then it increments the target loop. So it's going to iterate through all the entities and calculate all the angles, calculate all their distance, their position, their health, their data, their team, everything. And then it goes here and it checks if it's anything. If it's 0, it says no valid targets. And then here it goes into a target loop. This is where it sorts it. So basically, okay, this function compares two target list objects by their distance, returning true if the distance of A is less than of B, which effectively sorts the target from closest to furthest. Target list pointer is a pointer to the first element, this one, first element, and target list plus this one is a pointer to the last element plus 1. This is how it's done. So this is the first, and this is the last plus 1. I mean, no, this is the first, this is the first. This is them added together plus 1. So this is the beginning, this is the end. Okay, so what it does, this right here, this ascending order, smallest number first. If you had this going this way, less than, I forgot what it was, is descending order. So largest number first. So if you want to aim at the furthest target, you set it this. If you want to aim at the closest target, you set it to this. So this is what all that stuff means. And now this is the debug info. It's this is very important because if you have some issues with your hack, the debug info prints all this stuff. So basically, it lets you know if the debug info is on or off. And this is the game state. This looks kind of complicated, but I think I explain it a little bit better down here. So basically, this is just where is it? Where do I explain it? Okay, so the question mark means if statement is true, adds a space. The two dots mean if the statement is false, it doesn't have a space. So basically, this is just a complicated if statement. The 0 question mark, if 0, put default match. If 7, put that, right? And then this, or else it continues down this. So I showed you both ways of doing it. I forgot what this was exactly called. This is called a ternary operator. This is shorthand from writing all of this, the if statement. So I showed you both. So you could have wrote this using the ternary operator, or you can write it with the if statement. So basically, this is for the debug. You definitely want to have debug in your cheats. You definitely need that. So this is for the alignment. We're not there to show. I guess I could. Yeah, I guess I could. So you can follow along better. Just to show you what it looks like. What the hell did I do? This is for the alignment. Okay, so if you press F9, it gives you a debug text, and it just has it aligned correctly. But I'll explain everything as we go. So all this stuff is for alignment. It adds a bunch of spaces. It doesn't look that great. We add some spaces just so you can visually see it. So if your health is between that, it adds this much spaces. If your health is between that, it adds that much spaces. It's for alignment. It makes it look better. And this is just more debug text. And right here, this is just more alignment. This is all for the debug text. It prints, it does all this, which I just showed you. But I'll show you again. Press 9. It just formats it so nice like this. So it has everything underneath this. It lines up here. It lines up there. Hold up, distance? Their distance is way too far away. What the hell did I do? I think it's a map. Let me go on a different map. All right, there we go. Why does their distance have a huge number? Okay, I'm not sure why the distance is supposed to be this big, and it threw off my alignment. I don't know what happened because my the code I used earlier and the code I'm using right now has the same issue. I have no idea what happened, why the alignment is thrown off, and the distance is so big. It's not supposed to be a huge distance number, but it's not a big deal because the code still works. As you tell, the code still works perfectly fine, but I don't understand why the distance is so big. But it's no reason to try to fix it, I guess. If it ain't broke, don't fix it. I don't know what the hell what happened, why did it change. But back to where I was talking about. Okay, so this is, I was talking about the distance, I was talking about the debug. And okay, so damn, we're almost done with all this code. So basically, did I miss anything? I think I didn't. Since we're talking about the distance, we're gonna go here. Basically, get 3D distance is the hypotenuse calculation, right? X squared, y squared, z squared, and you get the hypotenuse calculation for this. So that gets the distance between you and the enemy. I'm not sure why it's a huge number, because before it was a small number, but I don't know what happened and why it changed, but it still works. The code works. But I guess that's what's left off to explain. And then this line of code, if you're holding, so aimbot functionality, right aimbot angles to your pitch and yaw unless the right mouse is held. So it constantly does the aimbot unless you hold the right mouse. So this basically writes to your rotation the aimbot from the target loop. Because basically it calculates the aimbot angles for everybody, and this gets the closest target in the loop. And then it deletes, it sets the target loop to 0 and deletes the target list pointer. It's important. And so this was the old main for the debug. This one's without the debug. Basically the same stuff. It prints off this one. You press number pad 9 to enable or disable the debug. Has a slight delay, so you can't spam it. And runs the aimbot with a 1 second sleep. And this is what it looks like. If you press 9, it gives you the entity list. It doesn't aim as good when you use the entity list, as you can tell. Oh yeah, and let me turn on my this is from the last video, unlimited recoil. And see, it doesn't aim as fast when you have the debug. The debug just for tracking. I mean, testing your code. See, it doesn't aim perfectly if they're running, because it has to write the screen. But if you disable it, it aims perfectly. So even if they're running, Aimbot tracks them perfectly. Yeah, I do not think I missed anything. There's a lot in this aimbot. So I guess let me go from the top to bottom. So what you need from the aimbot, I mean, we can close this off. This is debug. This is all the extra stuff is for debug. This is how simple the aimbot is. Basically, it gets the target list. I mean, it gets your entity list and creates a target list from it. And then it iterates through all the entities in the list and puts them in the target list, which it created here. Created a smart pointer, a vector. So it puts it here. So it knows all the distance. It knows all the angles, the position, their name, their health, their team, and the address. As you can tell from here, has all this info. It's consistent with let's reattach. See, it's consistent with this stuff. So all this stuff is going to be here. And then it checks if the target list is 0, that means you have no targets. And then it sorts them from the closest to furthest. And if you have the debug, it does the debug. And then if you hold right, it stops aiming. But if you don't hold anything, it does the aimbot. Yeah, I know this was a long video. So it was a long video. The entire source code. If you want to support me on Patreon. And with your support, you get the entire source code on Patreon. Thank you guys for watching, and I am out.